Welcome to the System Design series. In this video, we will explore the design of file storage systems. Let's get started. A file storage system is essentially a distributed system. It allows users to store, organize, synchronize, and share files across multiple devices and platforms in a secure manner. It provides a way for users to access their files from anywhere, at any time, while also ensuring that their data is protected. Let's discuss the core features of a file storage system. First, file management. Users should be able to easily upload, organize, and manage their files within folders. Next is synchronization. The system should provide real-time synchronization of files across multiple devices. Sharing and collaboration. Users should be able to share files and collaborate with others seamlessly. Finally, security and access control. The system must ensure encrypted storage with robust permission management to protect user data. Here's a high-level overview of the architecture of a file storage system. At the top, we have the client layer, which includes web applications, mobile apps, desktop applications, and application programming interfaces. These clients interact with the application layer, which consists of load balancers, web servers, business logic components, and authentication services. The application layer then communicates with the data layer, which houses the metadata database, the actual file storage, caching mechanisms, and content delivery networks or CDNs. Let's take a look at the database design for a file storage system. We'll need a user table to manage user accounts. It includes fields such as user_ID, which is a universally unique identifier, email, which is a string, username, which is a string, password_hash, which is also a string for security, created_at, which is a timestamp, and storage_used, which is a big integer. We will also need a file metadata table to store information about the files. This includes file_ID, user_ID, name, size, type, storage_path, and checksum all as strings. Here's a typical file upload flow. First, the client initiates a file upload request. Then the server validates the file and generates an Upload Uniform Resource Locator, or URL. Next, the file is uploaded directly to cloud storage. And finally, the metadata is stored in the database. Let's explore synchronization strategies for a file storage system. For event-driven synchronization, we can use WebSockets for real-time bidirectional communication and message queues for reliable event processing and delivery. When it comes to conflict resolution, we can employ either the last write wins strategy, which is based on timestamps, or version control, which maintains file history and allows rollbacks. Let's discuss some scalability considerations for a file storage system. Storage sharding. Distribute files across multiple storage nodes based on user ID or file hash. Content delivery network or CDN integration. Cache frequently accessed files globally for faster downloads and reduced latency. Load balancing. Distribute requests across multiple servers with auto-scaling capabilities. Microservices. Separate concerns. Upload service, metadata service, and synchronization service. Let's talk about security and performance considerations. For security, implement Advanced Encryption Standard 256 or AES 256 encryption at rest and transport layer security or TLS in transit, role-based permissions and Java Web Token or JWT tokens, and audit logging to track all file operations and access. For performance, use a caching strategy like Redis for metadata and content delivery network, or CDN for files. Also implement gzip compression for text files, as well as database indexing and query optimization. Here are some key takeaways for designing file storage systems. Design for horizontal scalability from day one. Implement robust conflict resolution for synchronization. Use microservices architecture for better maintainability. Prioritize security and performance optimization. Leverage content delivery networks or CDNs, and caching for global performance. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.